Sound design.
All right, so will the new overhauled Delay Finder in Smart help you with your main sub-alignments? So I published this article this week, and now I would love to take you through some tests in Smart, just like I do here in the article. So first, let's take a look at where this came from, or at least my understanding of it. One of the techniques that I learned at a Smart class was to look at the arrival times and the impulse response. So let's do that first. Oh, by the way, so here's a photo of my setup. I've just got a JBL 615M and a JBL 618S on the ground, grill to grill, and my microphone's there in the near field, equidistant from the low frequency drivers. So here would be the process as I understand it. Let's see what I have over here first. I think I've got everything flat. I've got my main and my sub, so let's mute my sub and let's make sure this is all out. Okay, and let's take a measurement. Signal generator here on pink sweep. Everything looks good. And go. Okay, turn this stuff off. I'll set the peak. And then, not octave, but 1/3 octave. And let's look at 100 Hertz. Okay, and I can zoom in, right click. Okay, so for my main speaker, it looks like I've got a peak here at about 14.4 milliseconds. I'll just put 4 milliseconds, so I'll write that over here. I think I already did, yeah. So 14 milliseconds, and then I'll measure the sub. Cool. And what does this say? This says it has a peak at 15.96. I'm looking at this number here. 15.96. So if I write that down, 15.92, 15.96, then if I subtract 15.96 from 14, I get 1.96. So this makes me think that I need to add 1.96 milliseconds of delay to my main so that it also arrives at 15.96 milliseconds at this area around 100 Hertz. So let's try that. 1.96 in our main. 1.96. And let's measure it. And there we go, 15.88. So that's really close to 15.96, which is what we wanted. Okay, so that's one way to look at these peaks in the impulse response filtered by frequency. And this can help us with our spectral alignments. Now, in the new beta version, if we head over to the transfer function, some of this stuff is built into the new delay finder. So let's do the same thing. Let me just make sure. I'm going to take this out. We'll measure the main. Will we? Oh, signal generator. Peak noise. No, let's do file. I have a file here that's a combination of pink and brown noise. Play. So first, that all looks fine. So I'll hit L to open the delay finder. I'll filter to 97 Hertz. And I'm just going to check it again to see if I get a different reading. Looks like about the same, so I'll insert that. And I'll just wait for the coherence to stop improving. Cool, then I'll save that as main native. And let's measure the sub. And I'm going to zoom into the low end here, and I'm going to refresh. Okay, so it looks like we're not aligned, and we're not within 60 degrees here. So let's see what the low frequency delay finder says. I'm sorry, I called it the low frequency delay finder. That's in SatLive. This is the delay finder of the beta version of Smart 8. Okay. So this says that the sub is arriving sorry, I shouldn't say arriving, but there's a peak in the impulse response at 4.42 around 97 hertz. So I can't add negative delay to the sub, so I need to add 4.42 milliseconds of delay to the main. So let's actually insert this delay. Then wait for a second. I'm just looking at sub native. And now let's go back to measuring main native. So I have a new delay time. So I want to capture this again. Okay, so what did my delay finder say? Oh, that seems like the wrong number. Let's try again. Oh, right, because I have to filter it. Okay, 4.21. So let's try 4.21 here in the delay. Great, that's it. So we'll just close this. And now I'll hide our old main trace, and these should be on top of each other now around 97 hertz. But they're not. Let me make this a little bit different color. Okay, so here's our main, and our delay finder just told us that now 97 hertz should have a peak in the impulse response. So I expected the phase traces to be on top of each other, but they're not. In fact, it looks like they're about 120 degrees away from each other. If I measure the delay and I filter to 97 hertz, it says 0, right? Now if I hit the polarity inversion, it still says 0. So what I'm getting from this is that there could be a polarity inversion, but the delay finder here is not going to tell me about that, especially since I'm looking at ETC and not Lin, and it's going to be really hard to see linear anyway at filtered down to 97 hertz. Maybe if I boost it up a bunch. Yeah, it's still pretty hard to see. But there we see that peak going down. Let's see what happens if I switch it. Okay, so there's the peak going up. So maybe I would have noticed this if I had been looking at linear. So let's check the sub now, just out of curiosity. So this peak is going up, but this peak over here is going down at 0. So that may be the sub that has a polarity inversion. So let's put this in. Let's close this and let's recapture our subtrace. So I'll call this one sub-native inverted. And now let's go back to our main. Okay, now they are closer at this frequency that I was interested in, 97 hertz. And I know I haven't explained why I'm looking at that frequency. I can talk about that in a little bit. But now they seem to be a little bit closer. So yeah, about 60 degrees off now instead of 120. And now it looks like all I need to do is make a small change. So what are we looking at here? This is S native. So now it looks like we can use less delay on the main. So let's do that. How much less delay? Well, I don't think the delay finder is going to tell me anymore because it's telling me that they're have peaks that are at the exact same time. So let's use a little bit of math. Looking at 97 hertz, we have 19 degrees and negative 42. So I'm going to say 42 plus 19, 61 degrees. And let me just type this out so you can see it. So 61 divided by 360 divided by our frequency, 96.7, times 1,000, so we can get milliseconds instead of seconds, gives us 1.75. 1.75. So we need 1.75 milliseconds less delay. Here we have 4.2. So 4.2 minus 1.75 is 2.45. Hope I did that correctly. Okay, let's take a look. There we go. So now we have matching arrivals here. And if I zoom in even more, yep, I would expect to see that these are within 60 degrees throughout the crossover region. Okay, so this was just to demonstrate that I think this new overhauled delay finder can be really helpful, but you'll still need the phase graph here to fine tune it in the end. And it also didn't tell me that I had a polarity inversion until I switched back to the linear view instead of the ETC. Okay, there's a couple more things I wanted to show you. Another thing I could have done is export this into phase invaders. So what I would do is I would take both of these guys here. I'm going to stop this. I would choose export to ASCII, and I just discovered that in Smart DI there is no export to ASCII, so you need to do copy to ASCII, then open a text file, make a plain text file, paste it in there and save that, then you can do it. Anyway, so here in Phase Invaders I've uploaded those two measurements. They should look like this. Let me zoom out, reset these. Okay, so it looks like this. Okay, it looks very similar in Phase Invaders. So what I would do is turn up the coherence blanking to get rid of some of the noise, right? I have really high coherence on these measurements because it's in the near field, so I can turn it way up. Okay, this is the area that I'm interested in, so I'll zoom in. And this is where I started. These were my native measurements. So the first thing I did was a polarity inversion. And then I did 2.45 milliseconds of delay, which would be, oh, but I need to do it negative because I'm only controlling the sub. 2.45. Cool. You can see that I'm doing really well. This pink trace is on top of this white trace. I've got a really high score of 97 over here. And what I can do now is see if I make any tiny adjustments, do I get a better score? And you can see it changed from 97 to 98. Okay. So I might want to play with this a little bit until I get, the highest number possible. And I would see that that's negative 1.48. So then I might want to go back over to my controller here and put in 1.48 instead. Yeah, negative 1.48 milliseconds. And then I can verify that in Smart. So let's take a measurement here. It's native inverted. Let's zoom in. Okay, and we can see that we've got good alignment here through the crossover region, and we can take a look at both of them together. And just looking at the magnitude trace here, let's store this. So M plus S, and this looks good. It looks like we have summation here through the crossover region. I can zoom in a little bit more. Looks good. If we wanted to compare to my last setting, what would that be? I can't remember now. It was something like 2.48, I think. It's not going to make a huge difference. Okay, and here we can see that with that change, I just have a little bit less summation down here and a little bit less summation over here on the edges of the crossover region. All right, so quickly, I thought it would also be fun to look at what if we didn't want this big overlap crossover region here? What if we wanted a much tighter Unity crossover? So let's get rid of all this. Let's recall this preset. So here I've got a 48 dB per octave Linkwitz-Riley at 96.7 on both my main and my sub. Very steep. And I still have the polarity inversion here. And I have this delay here. So I've already done this ahead of time. And I guess we can just work backwards. So let's see. Let's measure the main. We'll do this filtered. Cool. So we have a new delay setting because of the filters I just added, right? We can call this main with Linkwitz-Riley 48 at 96.7 hertz. And now we can measure the sub. Sub, and we'll just call this for now JBL PRX 615 plus 618 LR 48 at 96.7 hertz. JBL. Go. Play. All right, so here's our tiny little crossover now. So same trick here. I want to get rid of a lot of the noise, then zoom in down here. And it looks like this is not quite perfect, but that's because this was before I did any changes, I believe. So what did I have over here? 2.47 milliseconds. So I'll put in negative 2.47 milliseconds. That gives me a really high score, so I'm probably not going to get much better than this. I just wanted to check to see if I could get any better. I've got a score of 99 here. Will any small adjustments get me any closer? Maybe not. Oh yeah, it's going a little bit higher. So this says that a little bit better summation would be at 2.05 milliseconds. I can try that. 2.05, and then we can measure these together again. Let's hide everything except for our previous sum. Let's measure everything. And there we go. So this sum should be a little bit better than the previous one. Where is our actual crossover? So just for fun, if we zoom way in, and then we hide these again. So supposedly this one is a tiny bit better. I don't really see it. It looks the same to me. But that's how I can check my results in Phase Invaders. All right, so I'm wondering, have you tested out the new Delay Finder in Smart Beta? If you have, please let me know what your results were. And if you think there's a better way to do this, I would love to know. Thank you. Sound design.